Hello and good afternoon. Welcome to another episode of COVE Tenant Talks. Before we get started, let's get a few housekeeping items out of the way. Those who are watching, feel free to ask questions in the QA and chat functions using the tools at the bottom of your screen. And most importantly, I'll get those questions to the guests today, as I know we're going to have a very lively discussion ahead of us. And with that, I'm very pleased to welcome our first guest today, Dave Shea, Senior Vice President of Engineering at Kraken Robotics. Welcome, Dave.
Thanks, Kyle.
How are you doing today?
Not too bad. How are you doing?
I'm doing pretty well myself. Looking forward to our discussion. Perhaps we can get started with you telling a little bit more about yourself.
Sure, happy to. Well, I'm Dave Shea. Thanks for the introduction. I'm the Senior VP of Engineering for Kraken Robotics. I've been with Kraken since we started the company about in 2012. There was about 6 of us. We were based primarily out of St. John's, Newfoundland. Since then, we've grown a lot. We took the company public in 2015, and today I think we're about 112 people worldwide, with offices in St. John's, Nova Scotia, where I am here today, Toronto, Boston, and 2 offices in Germany.
Wow, that's quite a large international reach for what is a fairly new company.
Yeah, we've grown a lot in the past few years through mostly organic growth, through a couple of small acquisitions. And we've been very opportunistic in our growth as well, eyeing up a few key opportunities, as I'll talk a little more about today.
Perfect. Your presentation today, we're going to talk a little bit more about some of the projects you're working on, some of the products that you've developed and are working towards. Perhaps we can get started with that presentation right now.
Definitely. I'll go ahead and share that here with you.
Perfect. Looks great.
All right. Well, we'll jump right into it. First of all, we are a publicly traded company, so I have to put this forward-looking statement advisory in front of all my slides. I won't force everyone to read through it, but if anybody asks, you all read it in detail. So talking a little bit about Kraken, we're primarily a marine technology company. We started off our business focusing on sensors, specifically our synthetic aperture sonar back in 2012. That's really been our bread and butter for the past number of years, and that's what got ourselves out into this industry. Since then, we expanded into building components, including pressure-tolerant thrusters, pressure-tolerant electronics, camera systems, and subsea lasers in 2016. In 2017, we expanded the business further, moving up market and actually building our own platform. So that includes our actively stabilized towfish system, the KATFISH, our own autonomous underwater vehicle, the Thunderfish, as well as our jellyfish system, and our own handling systems, which I'll talk about. From there, we continue to grow up market and really diversifying our business beyond just selling products and selling systems, but into actually offering a service. So I'll talk a little bit more today about some of the robotics as a service, or RaaS, work that we're doing through our Ocean Supercluster project, as well as some of the really interesting work we're doing in data analytics as well. So just talk a little bit about synthetic aperture sonar, as that's really our core product and what we're probably best known for. So why use synthetic aperture sonar, and really what is it? Well, without getting too far down into the details, it's a very, very high resolution side-looking sonar system. The main advantages of synthetic aperture sonar versus a traditional side scan are that through the use of very intelligent software, we're able to synthesize an array that's much, much longer than the actual size of the physical acoustic array that's on the vehicle. That allows us to generate a very, very narrow beam width, which gives us a very high resolution out to very long ranges, and maintain a constant resolution across the entire swath. So I've got an example there that's very close to home here in Halifax. These are Volvos that were dumped in Halifax Harbor back in the 1960s. There's about 24 of these that were damaged in shipment when they came over from Europe. Because they were damaged, if they were to land with them, they would have had to pay duty on them and wouldn't have been able to sell them. So instead, they asked the Port Authority if they could just dump them in the harbor. And because it was 1969, they said, sure. So they dropped these, they took the wheels off, they took the engines out, drained all the fluids, and they just literally shoved these off the back deck of the boat in a line in the middle of Bedford Basin. So these are in about 60, 65 meters of water. The course, having been down there for quite a long time, they've started to corrode and degrade. We use them as resolution targets. You can see the upper image there from our sonar system. At about an 80-meter range, we're getting a 3 centimeter by 3 centimeter pixel on these targets. So we're able to see that the doors are open, the engines have been removed, we're able to see the roofs are starting to collapse in on themselves. And the image on the bottom there is exactly the same range with a leading side scan sonar system. So with that side scan system, where you have a much smaller aperture, that beam is spreading much more with the range. Therefore, you have a much lower resolution. So that's about a 20 centimeter resolution in that side scan image there. So just a little bit of background about our growth. As I mentioned, in 2012, we started relatively small in September 2012 with our first product, our synthetic aperture sonar. We continued to grow, selling those primarily in the defense market. In 2015, we took the company public. We're actually traded on the Toronto Stock Exchange, on the Venture Exchange. In 2016, we expanded into the US and Germany, and then continued our product growth moving up market. In 2019 and into 2020, we submitted our ocean supercluster project called Ocean Vision, which I'm going to talk a little more about later on. And that project is actually a 36-month program that we're continuing on for the next couple of years here. So as I mentioned, today we're about 112 people worldwide. So we've grown a lot in the past number of years. So I'll talk a little bit about the different technologies that we're using for our ocean supercluster project. The KATFISH is the Kraken active tow fish. And when I say an active tow fish, so this is towed from a surface vessel. You can see in the image on the left to the actual tow cable that attaches to the fish, but it's actively stabilized. So the control fins are in an X configuration on the back of the fish. There's an inertial navigation system on board, and it's actually moving those fins all the time to stabilize it underwater. Because as you're pulling this from the surface vessel, every time the boat's moving up and down, that's going to bounce the fish around. It can compensate for that with its fins and stabilize itself, which will ultimately yield a much better image, a much better, more stable picture of the seafloor. As well, it allows us to do things like bottom avoidance, obstacle avoidance. We can do bottom following, so we can work in very rough terrains and still maintain a very close image of the bottom. That whole system is designed to work on an unmanned surface vessel. So you can see on the right, that's an image from one of our customers using the KATFISH system on the back of that vehicle. So you can actually run that whole system. You can launch the fish. You can see all the data as it's streaming up the cable, and you can run it all remotely, either over a line of sight radio link or even over a satellite link. So these can be run over the horizon. As I mentioned, we work a lot in the defense industry. So the most common application for these systems would be in mine hunting or mine countermeasures missions. But we're seeing a much more larger adoption coming more recently in commercial applications, search and salvage, oil and gas, pipeline inspections. Just to show you some comparisons between SAS and classical multibeam. This was a search we had done a couple of years ago working alongside the Canadian Hydrographic Service. They had provided us some data of what they believed to be a World War II shipwreck that was on the bottom of the ocean just outside of Halifax Harbor. So this image shows about an 80-meter swath coming from a multi-beam sonar. This is in about 65, 70 meters of water. This is a 700 kilohertz multi-beam, so a very high resolution multi-beam system. We know it's a man-made object. We don't know exactly what it is, but we had high suspicions that it was this particular shipwreck, the HMCS Esquimalt. When we actually went out there with our SAS system, this is what we found. So definitely not a warship, but more interestingly, it was an 80-meter long barge that was completely uncharted. There was no record of it having gone down there. So even though it wasn't what we were looking for, still a very interesting result coming out. We can see that the sides of the barge have collapsed. We can see all the ribbing there. And of course, you're seeing some of the scour marks on the seabed where the sand waves are starting to erode around it. So this is a little video that I'll play for you while I speak. So the other technology we have, in addition to our acoustic systems, is an optical system called the Sea Vision. This is an underwater laser scanner that uses a red, a green, and a blue laser to dynamically scan over an object, and it builds up a point cloud in real time. So what you're seeing there in the embedded image is that actual 3D model being built up at the same time the operator's there scanning. So we use that for hull inspections like this, where we're doing an anode inspection or we're checking on a propeller. We also use that for a lot of subsea infrastructure inspections, or looking at cables, pipelines, various assets underwater. And the difference between the SAS and the Sea-Vision system, where our synthetic aperture sonar does a 3 centimeter pixel, the Sea-Vision will do a 0.9 millimeter pixel. At a much shorter range, it does about 10 meters of range, but much, much higher resolution. We use that a lot for mooring chain inspections as well. That's a big commercial application for us. And that system we actually operate as quite often as a service. So we'll send one of our guys or girls out onto a vessel with the Sea-Vision under their arm. We can bolt it onto either a work class ROV or an inspection class ROV. Because we don't need any inertial navigation input, we don't need any other sensors feeding into the system. You can just grab it in the grabber arm of the ROV, point it at what you're interested in, and it does all the motion compensation and all the laser line extraction within the system itself. We also have here in Halifax, we have a handling systems group where we're actually building an autonomous launch and recovery system, or the ALARS. So that system, as I mentioned before, the KATFISH is meant to go on an unmanned surface vessel. The problem with unmanned surface vessels are typically they're a lot smaller than a similar sized or than a similar mission manned vessel, meaning they're going to be much more dynamic in any kind of a sea state. Plus the fact that there's no people on board, meaning that the vessel can actually survive and operate in much higher sea states than you'd normally have humans deployed in. So launching and recovering the equipment safely is a real challenge, especially when there's no people on board. So the whole ALARS system has been designed to safely launch and recover not just the KATFISH, but any one of our systems in very high sea states. So we've deployed those systems along with our all-electric winch, which actually enables us to operate the system in a higher sea state, where not only can we launch and recover it as the vessel's moving around with that wave action, but the winch can actually do some surge compensation and heave compensation. So it's paying out and pulling in little bits of cable, helping to minimize the impact of the vessel dynamics on the actual towfish. The Thunderfish is our autonomous underwater vehicle. So this is an untethered platform. It's battery powered, using our own batteries that we build in Germany, using our own thrusters that we build there as well, and using a suite of our own sensor systems. So this is designed for actual seabed residency. So the intention of the Thunderfish would be to deploy it in an oil and gas field, or deploy it in a certain spot on the seabed where we want long-term monitoring. It could actually live in a garage on the ocean floor and go out every day, every week, every month, go out and do a mission, collect some data, whether it's sonar imagery or whether it's passive acoustic monitoring for fish tags, for fishing vessels, for potentially for submarines. And then it can come back to its docking station and recharge itself, or it can come up to the surface and actually transmit data back over a satellite link or something like that. So all those technologies, and I realize I'm going through this very quickly, there's a lot of different pieces. These are all the building blocks that help us build up what's called our Ocean Vision project, which is our Ocean Supercluster project. There are two components to that. One is what we call robotics as a service, and the other is data as a service. So the robotics as a service, in the scope of Ocean Vision, we can take our robotics out into the field. So they're owned by us, they're operated by us, we do all the data processing ourselves, and we can go out to sites of interest for our customers, collect data, collect information, not only seabed imagery, acoustic imagery, but optical imagery, oceanographic data, temperature, chemical data, conductivity, dissolved oxygen, all these different parameters can all be collected simultaneously. And we can do it at a much lower cost than a traditional company, because we're using our own tools. We build them ourselves. We can supply our own spare parts. We can actually deploy multiple assets. So we get a force multiplication effect of using multiple robots with only one vessel actually supporting them, or one mothership. And we're also operating something we call data as a service, where we're going out there and we're collecting information in the ocean all the time. And we're continuing to deploy these robotic systems, surveying various areas. In the scope of this project, we're focusing really on the Grand Banks in and around Atlantic Canada as a proof of concept. A lot of times we see companies in different sectors, whether it's the fishing sector compared to the oil and gas sector, they might be interested in data from the same regions or the same types of data, but they're not communicating with one another because they're completely disparate industries. We can go out there and we can be collecting all of this data, all of this imagery, all of this different environmental information, and actually license that back to these different companies, as opposed to someone having to pay us to deploy our own vessel to go out there for one bespoke campaign. We're out there all the time collecting data, and customers can just tell us, well, I'm interested in something in this area. If we already have that data, great, we can just offer to license that to them. Otherwise, if we don't have anything in that area yet, we can plan it as part of our upcoming field campaigns, collect some more information there. And essentially the model being that we can survey once and repurpose many, many times to many different applications and many different customers. The really interesting part becomes when we bring the cost of that data acquisition down so much, using the robotics that we are and using the quality of sensors that we're using, we can increase the frequency of data collection as well. And that allows us to start exploring really interesting things like automated change detection and different data analytics, where we can be surveying an area of the seabed. The classic example would be something like a pipeline, where you want to be surveying the pipeline and monitoring for freeze span, which is when the area under the pipeline has eroded. Well, rather than waiting until it's fully eroded, we can actually be monitoring those very, very small changes before that's happening. So before an event actually occurs, you can proactively inform the customer, and they can go and deploy some additional coverage or put a mattress on top or something like that. Or in other industries where we're looking at, for example, habitat monitoring. So we're out there collecting data in these different fishing areas. You want to see, well, are these areas actually ideal for, this particular species of fish? Are we seeing the same kind of stock? And when we're actually measuring the number of fish that are out there, measuring the quantity of habitat that's out there compared to the stock assessments that DFO is doing, and trying to correlate that all together and seeing, are we seeing changes in that habitat correlating to either fishing operations, correlating to temperature changes in the ocean, correlating to other chemical processes that are happening. So we have a lot of different partners in this project. I talk about what Kraken's technology is doing, but we're working with a large number of different partners in the oil and gas sector through Newfoundland Petroleum Research, Newfoundland and Labrador, with our fishing partners being Ocean Choice International, with a number of different other companies. We're also working with a lot of local SMEs within the scope of this project. We work very closely with Turbulent Research, who's a member of COVE, and Leeway Marine as well. And we're working with a few academic institutions in the scope of the project. So within the scope of the Ocean Vision, we have something called an SME Engagement Strategy. So the whole project is about $20 million. We've allocated a portion of that funding to actually allow us to work with academic institutions and to work with SMEs, to work with groups that either might not normally qualify for ocean supercluster funding, or might be too small or too early stage to be involved in the supercluster at this point. That allows us to take different sensors that they might have, to take different pieces of data, to share things and look at analyzing our data in different ways. One of the things we have, of course, in the scope of this project, we're deploying our platforms a lot over the course of these 3 years. So all of our platforms, the KATFISH and the Thunderfish, have reserved payload space. So we can take a third-party sensor and we can stick it inside the vehicle, and it can be collecting data if it has its own power source, or we can supply power to it. It can be collecting data all the way throughout our campaign, and then we can synchronize all that data. One of the recent examples, and I say recent, we collected this data just, that was this morning. Our system's out there being deployed right now on the Grand Banks. A company called Sedna, who's another COVE member, actually supplied us with one of their two of their little orbs. So this is the standard sensor package they have right now. It's battery powered, so it was very easy for us to integrate. We essentially stuck that in the nose of the KATFISH. We adjusted the trim and ballast so that it wouldn't have an effect on the dynamics, and we sent that out to sea with the system. We're collecting, with that particular sensor, dissolved oxygen and temperature at the same time. And what you're seeing in this plot here is actually that as the temperature drops, that's where the fish has actually dove down, and then we're surveying close to the ocean floor. In this case, we're probably 10 to 12 meters above the seabed, and we're seeing a correlation between the change in temperature and the change in the dissolved oxygen. Now, I'm not the marine biologist, so I'm not going to try and tell you what that means, but we're going to correlate all that data and then work with some of our more academic partners after the fact to look at, are we seeing any interesting correlations in different areas that we're working in, comparing that to some ground truth data we've collected in Bedford Basin and so on. So that is a very large nutshell of everything that we're working on in the Ocean Vision project, and really I just wanted to open it up to other SMEs that might be here, not just in Nova Scotia, but the scope of our engagement is really international. We can be working with companies all over the place, and we're especially interested in working with our Canadian local companies as well. But anyone attending the call can certainly feel free to reach out to us. There's both our standard info@Kraken email address there. My contact details are also there as well. And with that, I'd be happy to take any questions or answer any more details about any particular part of the presentation.
That's great, Dave. Really appreciate the overview and more information about how companies can get engaged. Because I know Seamus, for instance, the CEO of Sedna, has been very grateful and appreciative of being able to collaborate with a company like Kraken, and then also some of those supercluster partners that you might have. So I think it's a good entry point to test a product, but also maybe it could be a totally different market, because that orb, for instance, is more geared towards fisheries and aquaculture. How can this be applied to more scientific roles? Things like that might be of interest for companies to kind of think outside the box.
Yeah, that cross-sectoral collaboration is something that we're really keen on, and that's a key part of our whole project, is taking the oil and gas industry, the fishing industry, the hydrographic kind of classical government entities, and the defense sector, and cutting across all that and showing that you can use the same technology, and in some cases you can use exactly the same data to provide value to all these different verticals.
It's fascinating for sure. What about so we talked a lot about the platform, the data acquisition. Another piece of that probably is also software and artificial intelligence, correct?
Definitely, yeah. So we're internally both doing a lot of stuff around, AI is a big word these days, big buzzword. Everybody loves throwing in AI, deep learning, machine learning. We're doing a lot of stuff around the scope of data analytics with using deep learning systems to identify different areas of seabed. Doing classical like target detection is very straightforward if you have enough data, but doing some more interesting esoteric applications like actually identifying different types of seabed and being able to correlate some of the ground truthing like camera surveys and laser data with some of the acoustic data can help us actually help develop an algorithm that could potentially identify habitats, whether it's fishing habitats or identifying oil seeps is another good example for oil and gas exploration requirements. And really the core of any AI application that anyone's working on these days is data. The algorithms themselves have been around for a long time, but now we finally have both the computational power and we have the sufficient resolution and fidelity of data to be able to really leverage and exploit these algorithms. So we're working with a number of academic groups as well in leveraging their algorithms, but we're certainly keen to explore that with any other groups or partners that might be working in that area.
Sounds like the perfect time to really chase this opportunity. All the stars are aligning on data acquisition and some of the tools that can be used to unlock all that insight and value. Definitely. So speaking of trends, are you seeing those kind of similar type trends happening across all sectors or specific to certain ones?
So we've seen, and that's an interesting question. We've seen in the defense sector, there's always been a drive for very high resolution. And they want the best picture possible because those are mission critical applications. When we're talking about mine hunting, you really need to know whether there's a mine there or not, because you're trying to get boats in and out of a harbor or in and out of a particular site where you might be operating. And not just in kind of active scenarios, but there's a lot of historical unexploded ordnance all over the world. Not so much in Canada, although there is still some of that here, but definitely a lot in Europe and definitely a lot around the Middle East and the Mediterranean. So there's been always an interest and a keen driver in the defense sector for very high resolution. We've seen the oil and gas sector bringing those tools in probably a little bit more slowly. They want to see validation before they're really keen to jump on board. And now we're starting to expose some of the fishing industry who have been really focusing on optimizing their catch rates, optimizing their processing, optimizing their whole operations in different ways. Now we're starting to expose them through this project to this type of data that they're able to access. And I think now we're starting to see or expose these different groups to that real value, as well the cost driver. Like you can imagine, classically, this type of technology in the defense sector would be very, very expensive. This would be tier 1 defense contractor type stuff. Now we're saying, well, no, this is at a commercial off-the-shelf kind of price point. You can make this available for not much more than any typical multi-beam or side scan system. So it's you can really start to access a much larger market. And when you expose people to what you can really do with the data after the fact, that's the really exciting part.
I'm really interested in this space. This is kind of fascinating how it's all changing so quickly. We did have a few questions come from the audience, actually, so I'll happy to relay those. You spoke about your different offices around the world. Do each of those offices have a specialization at each location?
Somewhat. We all work very closely together, and everything we do is an amalgamation of all these technologies. For example, the Thunderfish and the KATFISH use parts from all our different offices. Some of the growth we've had internationally has been opportunistic. For example, in Bremen, Kraken Robotics GmbH, that's where the real science team behind our underwater laser scanner is based. So we manufacture the laser scanners in St. John's. That's where our production and engineering team is based. But we're the science for all that and the software is coming out of Bremen. In Rostock, Germany, we have a group called Kraken Power. That's where the pressure-tolerant batteries, pressure-tolerant thrusters, and pressure-tolerant electronics are being built. So that is a manufacturing facility that specializes, and a science and engineering team that specializes in that real pressure-tolerant systems. Those systems are all being used in the Thunderfish vehicle, which is actually being built in St. John's and being deployed here in Halifax. And then our Toronto team, similarly, they're working on a lot of passive acoustic systems that are being fed into our underwater vehicles. And then our US office is really focused on sales for the most part, business development within the US, especially with the US Navy, of course. That's kind of the behemoth in the defense sector.
Interesting. That is probably an advantage you guys had going into this kind of COVID pandemic, was you were already working remotely anyway. Your teams were kind of diverse and across the map. So it was kind of business as usual for the most part.
Yeah, I mean, COVID has impacted us as well, not as severely, and we've been quite lucky for that compared to some companies, through global diversification as well as through diversification of our sales channels, working not just in defense but in the commercial side as well. We had a few big contracts kind of going into COVID, so we were lucky to be able to focus on those. And then beyond that, even though sales cycles slid to the right as they did with many people, we've been able to really focus on a lot of the R&D programs that we already had ongoing, and the Ocean Vision project is a great example of that. Even though our spring campaign ended up being delayed by about a month and a half from where we wanted to operate it. So, for example, our team from Newfoundland was originally planning to come to Halifax to board the vessel and to go through all the shakedown on the equipment. Because I had a team here in Halifax anyway, and there was no travel allowed between the provinces, the team here in Halifax was trained up very quickly on how to do sea acceptance tests on the KATFISH system. We did all that testing here, and then we essentially sent an empty boat, except for the boat crew. We sent an empty boat to Newfoundland, and then all of our field crew got on the vessel there. So they were able to board and following very, very strict protocols on the vessel in terms of the COVID health restrictions, sanitization procedures, all of those things. So it's had not too much of an impact on us, thankfully, and we've been able to still push ahead a lot of our major strategic goals.
That's awesome. Let's actually end it there. I don't see any more questions coming in. I really appreciate your time, Dave. And I think everyone had a really good opportunity to learn a bit more about Kraken and the Ocean Vision project, which is really, really, really exciting.
Great. Well, thanks very much for your time.
Perfect. And before everyone heads off, I just want to give a quick update on who we're chatting with next week. On the next episode of COVE Tenant Talks, we're actually going across the pond to England and chatting with Gavin Willoughby. He's the business development manager at Applied Acoustic Engineering, and he'll be joining live from England. He's over there, but we're very excited to chat with him again, and see you all next week on Tuesday. Thanks, Dave.
Okay, thank you.